My name is Muhammad Haziq. Today, I would like to talk about the principle of concentration. The principle of concentration is measurement in analytical chemistry is to determine how much of substance is present by relating its physical or chemical properties like absorption, reactivity, voltage or mass to its concentration. Methods such as spectrophometry, titration, chromatography, and AAS use this principle, with calibration using standard solution to ensure accuracy. Definition: measurement of concentration refers to the process of determining the amount of substance present in a given volume of solution. It is a core aspect of analytical chemistry, which involves identifying and quantifying substance in a sample using various techniques. And why concentration is important in analytical chemistry? First, accurate result. Many chemical analysis and reaction depend on knowing the exact concentration. Next, quality control. Ensure safety and consistency in industry like food, pharma and water testing. Lastly, reliable comparison. Help monitor change across sample, especially in research and diagnostics. Thank you.
I am Waratul Amira. I will explain several types of concentration units. There are 4 main types. The first one is molarity, which is defined as the number of moles of solid per liter of solution. And the second type is molality. It measures the number of moles of solid per kilogram of solvent. And the third type is mole fraction, which is the ratio of the number of moles of a component to the total number of moles of all components in the mixture. The fourth type is mass percent, which is represent the mass of solid divided by total mass of the solution and multiplied by 100%. These are 4 main types ways to show how much of a substance is in a solution, and each useful for different types of calculations and situations.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noatira Najwa binti Zarusti. My number metric is 083558. Today I would like to talk about advantage of measurement of concentration. One is accurate chemical reaction. Knowing the exact concentration of reactant is essential for performing chemical reaction successfully and reproduct supply. Without accurate concentration, reaction may not proceed as expected or may yield unpredictable results. Second, environment monitoring and regulatory complaints. Measuring pollutant concentration is crucial for monitoring environmental quality and ensuring regulatory compliance. For example, measuring the concentration of heavy metals in water help ensure it meets drinking water standard. Third is safety. Accurate concentration measurement can help prevent accident and ensure safety, especially when working with strong acid, base or other hazardous materials. Last one is product development and quality control. Precise concentration measurement are vital in industry like pharmaceutical and food production. They ensure that product meets safety standard, have the correct dosage and are accurate level. That's all for me. Thank you.
Next, I will explain about disadvantages of measuring concentration. First of all is human error. In manual methods like titration or dilution, error in volume reading and endpoint detection can affect accuracy. Secondly, environmental or operating condition. Factors such as temperature, pH, light or pressure can affect the measurement accuracy, especially in field work. And the third one is limited sensitivity or range, which is some techniques or method may not detect extremely low concentration or might be inaccurate at very high levels. Last but not least is interference from other substance. The presence of other chemicals or impurities can affect the accuracy of the measurement, causing inaccurate result.
Good morning everyone, my name is Oyen Hao and my metric number is 082826. So today I will explain the function of concentration measurement in analytical chemistry. Concentration measurement tells us how much of a substance is present in a sample. It is the foundation of quantitative analysis, allowing chemists to get accurate and repeatable results. It also helps control chemical reaction. By knowing concentration, you can adjust reaction rate and ensure the correct ratio for reactant and product. In industry like medicine, food, and environment, concentration measurement ensures quality and safety. For example, correct drug dosage of detecting pollutants in water. Finally, understanding concentration helps scientists choose the right analytical method such as titration, spectroscopy, or chromatography. To sum up, measuring concentration is a key part of chemical work. It supports accuracy, safety, and critical decision making.
So next, I would like to talk about how measurement of concentration works. So we start with sample collection. So we need to collect a representative sample that free of contamination to ensure accuracy. Next, we do a selection of method. We choose an appropriate analytical technique based on type of analytes, required sensitivity and accuracy, and also metrics. So third, we use a sample preparation. We prepare the sample to make it compatible with the selected technique, for example, dilution, filtration or extraction and digestion. For fourth is we using measurement. We use a specific method to analyze the sample. For example, I thought just now, we use titration, spectroscopy, chromatography, gravitometry, and electrochemical. Next, we have data processing. We convert the measured signal into concentration using calibration curve, stoichiometric calculation, and Beer-Lambert law. Lastly, we use reporting result. So we express concentration in substance unit, mole, mg or ppm. Also, we include method details, purchase, and detection limit if needed. Assalamualaikum and hi, my name is Zulaila Natasha Binti Zahra Niza. My number metric is 081711. So today I would like to talk about techniques for measurement concentration. So first we have titration. Titration is a no solution is added until reaction endpoint is reached. For example, we use a sodium hydroxide in an acid-base titration. And next, we have spectroscopic method. This technique measures how much light a substance absorbs or emits at specific wavelength. A common example is UV-Vis spectroscopy, which can be used to measure ion level in water. Third, we have chromatography. Is another powerful technique because it works by separating the components of a mixture in a column and detecting them. An everyday application is measuring caffeine content in soft drink using HPLC. Next, we have electrochemical. Electrochemical is use electrode to detect voltage, current, and conductivity change. For an example, we use an pH meter or an ion selective electrode to detect a chloride. And finally, there are colorimetric technique. Colorimetric technique is analyte react to form a color compound, and the intensity of the color tells how much of something is present. For an example, is the nitrate that's in water using color strip.